Uh, Dr. Hacker?
You're back.
Sorry, I just realized I said pitching moment instead of angle of attack, which increasing pitching moment, it comes with your increasing your angle of attack. That, sorry, that wasn't the point. The point was, I just wanted your confirmation after seeing the design. We have it here on SolidWorks. So you recommended using this design as opposed to these two designs to have more stability for a rod, correct?
I mean, so your plate has the force sensors in it.
Yeah.
It's
The plate is attached to these four sensors. So we were either thinking of taking that entire thing and putting it on one single plate and tilting that and using coordinate transformations in order to get our values. Or we were also thinking of creating a little slot so that I can rotate around and track either by uh, using a jacket to hold the shaft in place, or we can still
so
create
is
the.
this the motor or what is it? That
That's the motor.
the motor's that big?
Uh, it's a rough estimation.
Oh, you haven't sourced a motor yet?
Not yet. We were. This was before we found a motor that had an encoder with it.
Oh, because you need to know
Yeah.
the speed.
Hmm? At different points of time. This would be our motor going through it, and the shaft is connected to it.
I'm just confused. How big your motor is, or what's the size? Where did you find your motor? I guess you have to use McMaster because that's the way life is.
We would have, but we decided to use good old Amazon.
Okay, Amazon is another option.
And alright, oh, there it is. That's the size.
Okay, so the shaft is considerably
At 4 millimeters, and then we were going to use an adapter to expand it to 6 millimeters. We couldn't find one to find anything bigger, but we were hoping to.
Why do you need to adapt it to 6 millimeters?
To get more stability for a rod to hold the frisbee.
Oh, okay.
Yeah.
So you're going to basically add a shaft.
Mm-hmm.
That motor. 600 RPM gear motor? So so the encoder has got the gear reduction. So it's 10-to-1 gear reduction on the encoder, not on the motor. Is that what it's saying?
Oh, that's for we understood.
Because if it's a 10-to-1, usually gear motors, the output's on the. Is 60 RPM sufficient if it is the other way?
Yeah, we needed it up to at least 6.8 revolutions per second, which is around 400 RPM.
I think it's a 10-to-1 reduction on the output as well. Just looking at it, for what they're describing it. So that might not actually work. Because what they're talking about, these are not running at 600 RPM. So maybe not. Because the motor is here, which means the gear reduction is here. Encoder is there. So I think that's going to be going way too slow. Does it have words on it that you need? Yeah, the gear is, so it's 10-to-1 output. So it looks like.
Do you want to try zooming in using the switch?
Yeah, that's too soon.
Oh.
They think they're helping, but they're not.
Yeah.
I don't know. I don't know. You can figure out. You can figure out what that is.
Okay.
That's a DC motor and encoder for measuring speed.
Oh, it has a coder with it?
Yeah.
Oh, okay.
So this is the encoder. That's the motor.
Perfect. Thank you.
So I have several of these if you need to, if this will work.
We'll take it into consideration as part of donation instead of using parts list. Well, with the motor accounted for, at least a change in motor for that, would you recommend us changing our design to include a slot in order to include your mounts where we have the bearing in the middle and we just change, the angles using the slot?
I mean, how easy it is to. How much do you have to tilt your table?
By at least, we were thinking 35 degrees, 25 degrees by Dr. Warren's standard. So 25 degrees in either direction. Both forward and back. No. 45 degrees is what we measured, what we found articles to be at the highest before it just crashes.
Okay. Are these, you're purchasing these strain gauge
Yes.
elements? Okay. So then the material. Doesn't matter. But these are really flexible. I mean, I don't know how. I guess your loading isn't that. But that was how they said to get your 6-axis.
Yes. In order to bend it, we had to attach rods to it, and we.
It might be easier just to find a way to tilt your table.
Okay, so just grab the entire assembly and essentially just tilt it.
Yeah.
Okay.
That way, everything is relative to your. I don't know. I guess that's an engineering design. But I guess you want this to be longer so you're not interfering with the air
Yeah.
as much as possible. So, yeah, I guess that's for you to figure out.
Right.
I don't know if I'd recommend either way. Either way could work.
Okay.
But, yeah, if you're going to tilt things, because you need to tilt in 2 different directions, right?
Only one, since it's a disc. Well, whatever forces is on here is the same as the forces on here, as Dr. Gordon explained it. Our a pitching moment would be the same as our rolling moment, essentially.
But there's a.
Our angle of attack would be the same as our rolling angle.
Would it be? Because the window's coming from a different direction.
Mm.
I think you would need both, but Dr. Gordon has thought more about this.
Mm. I wasn't sure how he exactly explained it, but he said we can translate the values coming from that forces in to find it for another wind direction using different velocity profiles.
I don't know.
Nah. But you would recommend this in order to at least tilt in one axis.
I mean, this works with one axis, but I'm not sure how. If this is a ball joint, then you probably can tilt in 2 axes.
Okay. We'll just include a slot and then see if we're able to tilt it, but if that's not possible with our time constraints, we'll tilt the entire assembly. And you recommended just using the MATLAB filter in order to filter our noise.
Yeah.
And if we find out we have a higher rotational frequency, to use notch filter.
Yeah. I think you should be able to take data for long enough that you can totally filter out the. Because you're looking for the constant value.
Mm-hmm.
So. The caffeine's so helpful.
Would we have to buy a notch filter?
No.
Oh.
You can. It's just a mathematical.
Oh, sorry. Yes.
Operation.
Perfect. Then.
I think there's a filter toolbox in MATLAB or signal processing toolbox. It has filters.
Perfect. Aside from that, from the material, you recommended aluminum. Other than that, I think that covered all of our bases. We just wanted you to see the design in order to be sure of our recommendations.
Yeah, so this is how they basically said to configure it to get the 6-axis.
Mm-hmm. Using This one.
Okay. Looks like it. So it does look right. And the loads are, your deflections are going to be minimal in your loads.
Yeah, our only concern is finding a coupler to join all these 3 rods together. We were going to use a 3D printed coupler and use epoxy in the middle in order to stabilize it.
I mean, that can work.
Okay.
I thought you were asking for materials, and I was thinking it was for what you're going to hook the strain gauges on, but you're buying pre-wired strain gauge stuff, so.
Oh, yeah.
Those are probably made out of aluminum.
Yeah, those are made out of aluminum. We're going to attach it to aluminum rods, and the main shaft that's going to hold our disc is going to be made of stainless steel.
Okay.
We're just trying to decide whether we should screw our disc using the shaft, basically screwing the shaft into the disc, or...
Well, you're going to need something other than a screw in the middle. You need to apply torque. And so, you're spinning the disc. So if you're just holding it in the middle, you're not going to get much torque. You need at least 2 points of contact
Ah,
for it to spin. You can't just put a screw down the middle, especially with your tiny shaft.
Yeah, we were concerned about it. Once it starts slowing down, it would start unscrewing itself due to lag. So, 2 points of contact you would recommend then?
Yeah.
Perfect.
So 2 screws, like a T at the top, at least.
Okay.
Not a X at the top. It's assuming that, so, yeah, do you want it to be non-destructive or destructive? Because if you're screwing it in, then you're drilling holes in your Frisbee.
We want it to be non-destructive as possible, but considering we're spinning while going against the wind while also tilting it, we're going to have to use a few non-destructive methods.
So again, that's your choice. I mean, you could have something that basically expands out to hold the Frisbee.
Yeah.
As well.
An inside clamp, essentially. That was one of our considerations, but we dropped it because of aerodynamics, but we might have to go back to that.
I mean, you might have to put holes in it just because you're dealing with aerodynamics and you want to minimize the effects of the clamping structure. But Dr. Gordon might have thought more about this than me, so we don't have an aerodynamics person. Dr. C is probably more. All of our fluid dynamics people are on sabbatical.
Yeah, it's a bit complicated to do this without that sort of advice. But as long as we have your recommendations for our vibrations, then that's good. Thank you.